6.1 Angles and their measures. This section is going to be broken up over 2 days. So in this video, I'm just going to talk about examples 1 through 7. Depending upon your background from Math 3 will determine how strong you are going to be coming into this chapter on trig and how prepared you're going to be. Some of these examples I am not going to cover as in depth because they are things that were covered in Math 3. Some of these things, some of the examples you're going to be seeing, you are not going to recognize because you have not been exposed to them. So whatever questions you have, make sure you do write them down for when I do discuss this in class with you, or so you can come in and ask me before school lunch or after school to clarify any concerns or questions that you have. You will need a calculator. If you have your old unit circle from last year, that will be very, very helpful since I have not discussed the unit circle with you yet. But it's a nice thing to be using to refresh your memory. There should be some notes on your unit circles to help prepare you for this chapter. So today we're just starting with angles. That's all we're going to be looking at, both degrees and radians. In one full revolution, there are 360 degrees. If I start in the upward direction, it's positive 360, and if I start in the downward direction, it is negative 360. Along with the angle measures in degrees, there's also radians. Radians is the distance that you're actually traveling on the circumference of the circle. So if I have a coordinate plane and I have a circle here, and let's say I'm only going to walk from here to here, that distance is your radian. That is that chunk of the circumference. Hopefully some of these terms are familiar to you. We are going to start the review today with just looking at the angles and drawing them. Where do these angles take place on the circle of revolution, the 360 degrees? We're going to come back to these notes in a minute. They are very important for examples that are coming up. This set of examples here outlined in our notes, outlined in blue, are going to be for examples 2 and 3. And the notes outlined in yellow will be for examples 4 through 7. So you will need to be referencing back to these. I will as well. But right now we're just going to start with drawing angles. When you draw an angle, you start with your pole, which is your vertex, and your initial side. Your initial side is always at the 0 degrees. 60 degrees. 60 degrees is in between 0 and 90. So it's closer to 90. So I'm going to draw it closer to 90, but it's an estimate. So I want to make sure in my drawing of the angle that I included that I went up, which makes it positive 60. And I actually want to include that it is 60. You don't want somebody to guess what you drew. You need to make sure you include the arrow because how do I know you didn't go in the downwards direction and make it negative? So definitely show the direction in which you are intending this to go. 540 does not fall within the 360 degree revolution. So I need to figure out where it does fall. So I'm going to subtract 360 degrees. Well, I end up with 180 degrees, which does fall within my area of revolution. So I'm going to start with my pole and my initial side. Well, 180 degrees is on the opposite end of the initial side. But that's not what I'm graphing or drawing. I'm drawing 540 degrees. So what do I have to do for my arrow, how I showed the direction here? I need a directional arrow that is going to show me that I did travel 540 degrees. So I'm going to start on my initial side. It's important that you always start on the initial side. And if I go up and down and around, that is 360 degrees. And then I had 180 left there's the 180. So each full part of your spiral, as you spiral back to that initial side, is 360 degrees. My arrow is showing that I did go up and around, and then I'm going to show that it was 540 degrees. All right, now I'm moving on to C. C is in radians. I know C is in radians because it doesn't have the degree symbol. 16 pi over 3, there are two ways that you guys can find this angle measure on your unit circle, or where it would be located on your unit circle. One method is to just divide 3 into 16. 3 goes into 16 5 times with 1/3 left. So now I'm looking at just the radians. You could also convert 16 pi over 3 into degrees. And this should be a review from last year. And it's also an example that's coming up. To convert from radians to degrees, you're going to multiply your radian by 180 over pi. Here the pi's cancel, and I'm left with 16. I'm using my calculator. 16 times 180 gives me 2880, and then I have to divide by 3, which gives me 960 degrees. That's not on my unit circle or within the 360 degrees of revolution. So I'm going to subtract 360. Well, that gives me 600 degrees. That still is not inside my 360 degrees of revolution. So I'm going to subtract 360 again. And when I do that, I end with 240 degrees. That does fall within my 360 degrees. So I start with my initial side and my pole. I'm going to explain this two different ways. I'm going to start with the degrees. 240 degrees is between 180 and 270, but closer to 270, so maybe somewhere over here. But I have to add my arrow of direction. And don't forget that also must show how many times you're spinning around that circle. So I subtracted 360 degrees twice. So I'm going to go 1, 2, and then I went to 240. So this is my 960 degrees. That's one way to do this. Another way is with the pi's, with the radians. So we need to remember 2 pi is equal to 360 degrees. And 1 pi is equal to 180 degrees. So I'm not exactly sure where I'm supposed to end yet because of this being 5 1/3 pi. So I'm going to start with my spiral. Every half of a turn is 1 pi. So you probably want to watch first instead of drawing. 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. Now I just need 1/3, so it's just a little bit more. And then I end up at pretty much the exact same spot as the 200. Well, it is the exact same spot as the 240. Your drawing just might be off a little bit. But this is 5 1/3 pi, or 16 pi over 3. Now I'm going to look at D. D is negative 2 pi over 3. If I multiply this by 180 over pi, pi's cancel, and you're left with negative 360 over 3. I'm going to just double check with my calculator. There's nothing wrong with using your calculator. And when I divide by 3, I get negative 120 degrees. When you are graphing in the negative direction, so you still start with your pole and your initial side. Look at your unit circle. Actually, I'll come up here and look at this. Let's find where positive 120 degrees would be. Positive 120 degrees is going to be between 90 and 180. and it is going to end up being closer to 90. So this would be drawn this way, but to get it to be a negative 120, I flip this down here and it's going to be in that direction. So we do end up getting a reflection here. So instead of being up in this direction, I'm actually going to draw it facing downward in that direction. And I'm going to draw my arrow going down, and I'm going to say it's negative 2 pi over 3, or negative 120 degrees. All right, so that's drawing of angles. There's other angles that you guys can draw, but that's just the gist of it. Now we're going to look at converting from degrees, minutes, and seconds to just degrees. This is used when we are looking at maps, when we are trying to locate something on a map, or somebody is saying their location on a map as maybe a heads up, this is where I'm at. They're on a boat and they're just checking in. So that way the Coast Guard or whoever might be looking for them if there is an accident knows about where to look. So I need to convert this completely into degrees. If I look back at my notes here, I'm going to rewrite them with this example. One degree is equivalent to 60 minutes. This prime indicates minutes. So this little prime is minutes. And when I see a double prime, that means seconds. So 1 degree is the same as 60 minutes. And 1 minute, I hope we know, is the same as 60 seconds. From this, I know that 1 minute then, if 1 degree is 60 minutes, 1 minute is the same as 1/60th of a degree. Let me make sure I've written everything down that was up here. Okay, looks pretty good. Just a little bit more I'm going to add, but I'm going to add that when we start working on this example. So I have 1 minute is equivalent to 1/60th of a degree. That's what I'm going to use here in this example. So I already have the 73 degrees. That's not what I am converting. I am converting the minutes and the seconds. So if I'm looking at 40 minutes, I want to convert this to degrees. Well, 1 minute is 1/60th. So I need to take the 40 minutes and I need to multiply it by 1/60th. And I'm going to add to it. Now I need to convert the seconds. 40 seconds. Well, to convert it to minutes, I multiply it by 1/60. And then I have to convert this to degrees. So I need another 1/60. This is coming from the fact that there are 60 seconds in 1 minute. So I do need to multiply this twice. So here I end with 40/60 plus 40/3600. And then just go ahead and use your calculator. I'm not worried about that here. This ends up being 73 point something degrees. So I'm going to use parentheses. 40 divided by 60 plus, new set of parentheses, 40 divided by 3600. Please make sure you use parentheses. And this ends up being 6.67777. So it says round to 2 decimal places, so 0.68 degrees. So let's do this one more time. 6 minutes. I need to change this to degrees, so I multiply by 1/60. 1 minute is 1/60th of a degree, and I have 6 minutes. And then I have 21 seconds. So I have to convert that first to minutes, and then I have to convert it to degrees. So this becomes 6 over 60 plus 21 over 3600. So this is going to be 50 from the degrees, point something. Again, I'm going to use my calculator and parentheses. 6 divided by 60 plus 21 divided by 3600. And I end up with 1.1058, and the 5 will round the 0 to a 1, so 50.11 degrees. So that's converting from degrees, minutes, and seconds to just degrees. Now we're going to convert from degrees to degrees, minutes, and seconds. This is actually a lot easier. This is already your degree. This is your degree, the 21. But the 0.256, that's just a portion of a degree that we need to convert to minutes and seconds. So I'm going to take the 0.256 degrees, and the first thing I want to do is convert it to minutes. So to convert it to minutes, I need to multiply by 60. See, 1 degree is 60 minutes. So I'm taking this 0.256 and I want to multiply it by 60. So when I do that, 0.256 times 60, I get 15.36. This is your minutes. Now I have 0.36 of a minute left, but now I have to convert that to seconds. So it's already in minutes, 0.36 minutes. And when I convert it to seconds, I just need to multiply by another 60 because there's 60 seconds in 1 minute. And when I multiply 0.36 times 60, I get 21.6, which rounds to 22. So my final answer ends up being 21 degrees, 15 minutes, and 22 seconds. So let's do this one more time. Here's my degrees, and I'm going to take the 0.255, and I'm going to multiply it by 60 to get the minutes, which gives me 15.3. That's my minutes. Then I take the 0.3 and I multiply by 60 again to get the seconds, which is an even 18. So I have 18 degrees, 15 minutes, and 18 seconds. It's a lot easier to go from degrees to degrees, minutes, and seconds instead of degrees, minutes, and seconds to degrees. The conversions are, they just make more sense. You're multiplying by 60 to get the minutes because there are 60 minutes in 1 degree. And then you multiply by 60 again because there are 60 seconds in 1 minute. So hopefully it makes sense. If not, you can ask me or in class or just come in at lunch or before school, after school. Now the last 3 examples that I'm going to go over are 4 examples. 4, 5, 6, 7, 4 more examples are relatively simple. They are review from last year, so I don't want to spend a lot of time on them. When you're converting from degrees to radians, you are going to multiply by pi over 180. So I take the 120 and I just multiply by pi over 180. I get 120 pi over 180. You are not allowed to have your answer in decimal form, so you do need to simplify your fractions. The zeros cancel, and then I could divide by 6 over 6, which gives me 2 pi over 3. And you just go through the same process. Negative 30, and then it's multiplied by pi over 180. The zeros cancel. I get negative 3 pi over 18, which is negative pi over 6. 240 times pi over 180. I'm going to cancel the zeros again. I get 24 pi over 18. I can divide by 6, and I get 4 pi over 3. I know that was quick. If you need to watch it again, watch it again. Number 5, again, review from last year. When you're converting to degrees, you're going to multiply by 180 over pi. I need the pi to cancel, so this is no longer in radians. So I have 5 pi over 6 times 180 over pi. Pi's cancel. Now I am just going to go ahead and use my calculator and see if it works without giving me a decimal. 5 times 180 is 900 divided by 6. And I get 150 degrees. So that worked out good. Negative 2 pi times 180 over pi. Pi's cancel. I get negative 360 degrees. And then here I'm just going to be a little lazy. I'm going to put the pi. 5 times 180 again. 900 over 12. 75 degrees. Not too bad. You just have to make sure you remember when you use which fraction. All right, last 2 examples. Convert to radians. So this is multiply by pi over 180. So 17 times pi over 180. Well, 17 does not go into 180, but if I look at the directions, it does say I'm allowed to have 2 decimal places. So I'm going to have 17. I'm going to use the pi button, so 17 times pi, and then I'm going to divide by 180. And I'm going to end up with 0.30 radians. Here, negative 51 times pi over 180. So negative 51 pi, and then divide by 180. And I get negative 0.89 radians. And in the last example for this video, convert to degrees. So that is 180 over pi. So 0.75 times 180 divided by pi. So 0.7, I'm using my calculator. 0.75 times 180, and then I'm going to divide by pi. 42.97 degrees, it says 2 decimal places. 3 times 180 over pi. Using my calculator, I end with 171.89 degrees. So that's really a quick overview of angle measures, whether it's degrees or radians, dealing with converting from degrees, minutes, and seconds to just degrees and vice versa. Any questions you have, please make sure you have written them down, or if you just need to watch this again or need any clarifying things, make sure you're ready with those for tomorrow, and I will see you then.